too.
Good. You must be coming down to where your finals are pretty soon.
Yeah, I've got my final on Monday.
Okay, so this is going to be our last session.
Yeah.
Okay. You going to verbalize stuff, or you want to send me a picture of something? Review material or something?
I think just verbalizing, because the review that he gave us had like 120 questions.
Okay. Well, you pick the ones you want to pick.
Okay. So, first...
That's usually what happens the night before the final, is I get review packet that's the entire semester's worth. So.
Yeah. So first I think exponentials.
Okay.
So one of the example problems is ln of x equals -4,
Okay.
and it says solve.
Solve for x?
Yeah.
Okay. If you convert this to exponential, what do you get?
Is that where you put an e on both sides?
Well, here's the thing. This is the same thing as this. And then converting it to exponential is the number on the far left raised to that power equals that number. So you would have e to the -4 equals x. And that's a number you can get out of your calculator. In fact, that's the only place you're getting that. Okay. Now, the method that I believe you talked about is probably this method. It's actually more complicated, though. I mean, it's really helpful if you know how to convert a logarithmic expression to an exponential. But you could always accomplish the same thing by making the left side of that equation the exponent to e, and making the right side of that equation the exponent to e. Like that.
Mm-hmm.
And this becomes x. So you get the same answer.
Okay.
This is really more of a pre-calc than a calc question.
Right.
Okay, go ahead.
So then another problem is 7 to the x power equals 3e to the x squared.
Like, I'm not quite sure I understood you. Is that what you mean?
3e to the x squared.
I'm still not hearing you. What? 3 to the what?
3e to the x squared.
Okay, now I heard. Yeah. I didn't hear the e.
No, that's okay.
All in parentheses or not?
No parentheses.
Okay. It matters, because if I put parentheses around it, then the 3 is also being taken to the x squared. Whereas the way I have it written now, it's only the e that's being taken to the x squared.
Okay.
It's the best first step here.
ln both sides?
Yeah. This is kind of a difficult problem, I think. What's the second step?
So then, does the e cancel out on the right side of the equation?
Remember the rules of logs. And certainly for calculus purposes, The most important rule of logs is being able to take that exponent and put it down in front on the algebra line.
Mm-hmm.
In other words, I'm going to take that x, put it down there. I can do that. And I'm going to take that x squared and put it down there. I can do that. So I end up with x ln 7 equals x squared ln 3e.
Okay.
Now, one thing you definitely do not want to do here is divide both sides by x. And let me just caution you about that. If 0 was an answer, you would lose it if you divided both sides by x. You would not come up with that answer. If 0 is ever an answer and you divide both sides by that variable, you will always lose it.
Okay.
Now, which means what we really want to do is subtract the left side from the right. And now factor out an x so that you have this. And the really important thing to remember when you're dealing with logs, they're just numbers. That's a number.
Mm-hmm.
3 is a number, e is a number. And that's a number. So in order for that to be equal to 0, what has to be true?
They have to be equal to each other?
Well, first of all, I've got the product of two things. That times that equals 0. What does that allow me to say? This is probably the primary first law of algebra. When you have two things multiplied together that equal 0, one of them has to be 0.
Okay.
So, first of all, either x is 0 or x ln 3e minus ln 7 is 0. And if I solve that for x, I get ln 7 divided by ln 3e. So there's your two solutions. And again, remember, this is just two numbers you can get out of your calculator. Now, it's not often that you have to get the ln of 3 times e. One might mistake that to be the ln of 1, or rather 3. That answer is not 3. The ln of 3 times e is the ln of 3 plus the ln of e. That's 1. That's some other number that you'd get out of your calculator. It's actually greater than 1. So this number would be 2 point something. But the fact is that once you get your answers in terms of logs, they're just numbers. Don't forget that. A lot of people look at these natural logs and they're like a deer in the headlight. They don't know what they're looking at. But remember that it's just a number. Okay, what else you got, Brianna?
propagated error question.
Still not hearing you that well. Hold on, let me turn my volume up a little bit. I have it down a little bit. Okay, go ahead again.
A propagated error question.
Still didn't hear that.
A propagated error question?
Propagated error?
Yeah.
Ooh, okay. I'm not sure what that even means. Go ahead. Maybe that's why I didn't hear it twice in a row. I didn't want to. What's the question?
It says, determine propagated error and percent error for the volume of a cylindrical tank with the radius measured to be 10 meters, accurate to within plus or minus 0.01 meters, and a height equal to the radius.
Next question. I hate to say that. This is a question that I get maybe once every 4 years. Not sure why you're getting it. Especially since the two previous questions were not calculus at all, but pre-calc. And then all of a sudden we have a calculus question that is extremely difficult. I might be able to figure it out relatively quickly. I'm thinking propagated error means dy dx. But I don't want to waste 20 minutes of your time working on this problem. So I tell you what, let's do your others and come back to this if we have time.
Okay.
Okay? I hate to tell anybody that, but some of this calculus stuff, if you don't get questions more than once a year, it's hard to stay on top of it.
No, that's okay. So the next one is, given a function f of x equals cosine squared of x, find f double prime of x.
Okay. What is that propagated error question doing in there?
I don't know.
I mean, that was like the super black ski slopes. And these other problems are like all beginner slopes. So I'm a little puzzled, but okay. So they want the second derivative, right?
Yeah.
So the first step is always to take the first derivative. Now, that's easier said than done. What's the derivative? There's two ways to do this. First of all, it's worth knowing that cosine squared of x is cosine x times cosine x. So if you didn't know how to do it, you could apply the product rule and do it.
Right.
Okay? However, you want to be able to do this using the chain rule. And the chain rule says the derivative of the outside times the derivative of the inside. Tell me what the inside is. If I had to make something the inside, what would it be?
Cosine of x.
Yeah. And whenever you know what the inside is, well, what's u prime?
Negative sine of x.
Okay. So, now, let's go back. I know what the derivative of the inside is. So, let's start by the derivative of the outside.
So, would that be 2 cosine of x?
Yes. In other words, it's u squared, which means 2u. Okay? Now what's the derivative of the inside?
Negative sine of x.
And I'm going to put that negative sign there. Okay, so there's our second derivative. There's our first derivative. Now, there's a couple of ways to get the second derivative. First of all, we could just apply the product rule. Let's do it that way. That's going to be your easiest way, I'm sure. And then I'll show you a different way that would probably be a little easier if you knew the trig identity for this. Do you happen to know the trig identity for that?
Is it 1?
It's minus sine of 2x. In other words, the double angle for sine is 2 sine cosine. And if we had this as minus sine of 2x, it would actually be easier to differentiate because we wouldn't need the product rule. We would just apply the chain rule again. But let's do the product rule. Product rule isn't that hard, and we can probably use the practice. So if I'm going to apply the product rule here, what is it?
So it's negative 2 times sine of x.
Let's start again. I always have problems with students when they're applying the product rule. Because, here, let's talk about that. If y equals u times v, y prime equals, well, it's uv prime plus u prime v, or you can reverse these. In other words, it could also be that.
Right.
And I never know which way a student is going. So I kind of tend to recommend students choose one way or the other. In other words, it's true that the arithmetic property allows you to add two terms in either order, but it's just confusing to both me and the student when they choose the order randomly. So I suggest everybody do it in this order.
Okay.
Always do u first and then v prime, and then of course add the reverse. Okay? So if we're doing u first and then v prime, what's u?
Negative 2 cosine x.
What's v prime?
Cosine x.
Now do the reverse.
So that's negative 2 times sine x.
What's the derivative of cosine?
Negative sine.
So it's actually two negatives. Right?
Right.
Okay. Now notice what we have. We have minus 2 cosine squared x plus 2 sine squared x. Well, that can be simplified, believe it or not. First of all, what can I factor out? Sorry, it cannot be simplified. Well, it can be simplified a little bit, but you don't really have to. What I was thinking was cosine squared plus sine squared is always equal to 1. I was going to simplify it based on that, but you don't get cosine squared plus sine squared. If you factor out a minus 2, you get cosine squared minus sine squared. That's actually cosine of 2x. So it does simplify, but I'm not sure that they would want you to necessarily. In other words, I don't think you would lose points. I don't know. This would be my favorite answer, but it would be hard for me to imagine that they would take off points if you gave them that answer. Now, if I go back here to this step and I realize that I'm looking at, oh, that's the same. In other words, f prime of x is the same as minus sine of 2x. The double angle formula for sine is 2 sine cosine. Okay, so this probably is a little easier to take the derivative. In other words, if I want to take the derivative of this over here, I'm going to take the derivative of the outside, which is minus cosine 2x, times the derivative of the inside, which is 2. So I get that much quicker. Notice that that agrees with that.
Yeah.
The difference is that applying the chain rule is easier than applying the product rule. When I did it using the product rule, it was like 3 or 4 steps. When I did it using the chain rule, it was 1 step. But it was actually 2 steps because I had to know my trig identities. But if there is one thing you want to know in calculus, it's your trig identities. I would say of algebra, geometry, and trig is the most important for calculus. There's a lot of calculus problems where you have to solve it by trig, and you have to know your trig identities. So, but either one works here, and they both produce the same answer as they always would.
Okay.
All right, so what else do you have?
Find the absolute extrema for f of x equals 2x over x squared plus 1 on the interval -2 to 2.
Brackets or parentheses on that?
Brackets.
Okay. Absolute extrema. Absolute extrema comes where? Let me ask you that.
When the maximum and minimum are at the greatest point, or the least point.
If I had a function over here, and I drew it like that, that's a local extrema. That's a local extrema. But if I said to you, where's the absolute extrema on this interval, where would the absolute minimum be? Be over here.
Yeah.
The absolute maximum would be there. So there's a difference between local and absolute. And the biggest difference is you have to check the endpoints when you're dealing with absolute extrema. If I'm merely looking for the local extrema, notice I can find that wherever the first derivative is 0. So when I search for local extrema, I'm going to take the first derivative, set it equal to 0, and go from there. But if I'm looking for absolute extrema, I have to check not only those points that might be local extrema, but I also have to compare them with the endpoints. Because the endpoints might be the absolute extrema. So I'm going to do a few things here. First of all, I'm going to figure out what f of prime of x is. If you're doing a calculus problem and you never know the first step, or if you don't know the first step, always assume that you have to take the first derivative.
Okay.
Okay, that's just the first step in like 95% of the problems. So, it really is. So what's the first derivative
So, the 2 times x squared plus 1.
here? Hold on. How do you memorize the quotient rule? Tell me what you use.
The derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared.
That's fine. It's different than how I memorize it, but it's the same thing. So,
Okay.
got the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared, right? Do I have that right?
Yes.
Okay, now I can clearly see that by simplifying the top, I'm going to be able to eliminate some stuff. So it's 2x squared plus 2 minus 4x squared. On the top, all over x squared plus 1 quantity squared. And the top becomes minus 2x squared plus 2. Correct?
Correct.
So that's our first derivative. Now, first step is to figure out where the first derivative is equal to 0. How am I going to do that? In other words, we want to figure out where the, if we're looking at a relative extrema, relative extremas always have a first derivative that's 0 because their tangent line is horizontal.
Mm-hmm.
Now, just in case this looks like it could be simplified, it really can't. If I take a 2 out of the top, it changes it to this. When you first look at it, it looks like you can end up with an x plus 1 there. But
Yeah.
you can't.
Okay.
Okay? So, this is f prime of x. Now, the question is where is that equal to 0? How do I solve that equation?
You set the numerator and denominator equal to 0.
Just the numerator. I really don't care what the denominator is. For
Okay.
that thing to be equal to 0, the numerator has to be equal to 0. That's the only way. In other words, if the numerator is not 0, then the whole thing is not ever going to be 0. Okay? So I can ignore the denominator. I'm not going to erase it yet, but because we still want to analyze, no, I can't erase it. I don't need that denominator anymore. Let's set that equal to 0.
Okay.
Of course, I can divide both sides by minus 2, leaving that. Okay? So now I have x squared equals 1, x equals what?
Plus or minus root 1.
That's the two places where the horizontal tangent line would be 0 on this function.
Okay.
So we're going to evaluate the original function at both of these, and we're also going to evaluate it at the end points. And that's going to tell us the absolute extrema and the relative extrema. So let's start. F of 1 is what? And you always go back to the original function. Remember what the purpose of derivatives is. It's to give you information about the original function.
Okay.
Okay, what's f of 1?
2 over 3, so 1.
What's f of minus 1? Those were our two places where we knew we had a horizontal tangent line.
That'll be -1.
And then we have to check the endpoints, because maybe the endpoints represent our absolute extrema. They're probably not going to be relative extrema, but they might be absolute extrema. And we have to choose from these 4 points. So what's f of minus 2?
-4 over 5.
And finally, the right-hand endpoint is what?
4.
Okay, now we're in a position that we can say what the absolute extrema in this interval is. What's the absolute maximum?
1, 1.
Correct. What's the absolute minimum?
-1, -1.
Good. And that's the way you do the, most of the time calculus questions are going to ask you about relative extrema. Or they will say, what's the extrema over a particular interval? Whenever they're asking about absolute extrema, always remember you have to check the endpoints. That's the biggest difference, is you really have to check the endpoints.
Okay.
What else do you?
Find the points on the graph of y equals x squared minus 3 that are closest to the point 0, -2.
That's what your function looks like. It's
Okay.
a parabola at the origin, shifted down by 3 units. And you want where on the graph is it closest to that point?
No.
Well, do I have that right? 0, -2?
Yeah.
So the question becomes, is which of these lines is the shortest? That line, 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 so forth and so on, that line.
Right.
Well, it's pretty easy to look at this and think that this is the shortest distance. In other words, the vertex of the parabola.
Yeah.
But we really don't know. In other words, it really becomes a calculus problem. What we want to do is we want to figure out the equation of a line that connects that point to the parabola, and then we want to minimize that. We want to take the derivative of it, set it equal to 0. That's how you minimize or maximize stuff. In other words, this is an optimization problem. And we have to optimize that distance. Well, what's the distance formula?
E equals the square root of x minus x1 squared.
Good.
plus y minus y1 squared.
It's actually y2 minus y1.
Oh, okay.
You're confusing it a little bit with point slope format, where you just have y minus y1 and x minus x1.
Oh.
But this is a little different in that we have an x1 comma y1 right there, and over here somewhere we have an x2 comma y2. Okay?
Mm-hmm.
So let's fill it in. The distance between that point and our parabola is x2 minus 0 plus y2 minus a minus 2 squared. You with me?
Yeah.
Okay. Now, that simplifies to x squared plus y plus 2 quantity squared. Because we no longer have the x1 and the y1. What we don't know is where is x squared, or excuse me, x sub 2 and y sub 2. So that, when I refer to x and y in this formula right here, I'm referring to that x and y.
Okay.
Okay? But this is the distance between those. And furthermore, I know from the formula that y equals x squared minus 3, right?
Yeah.
So I can substitute what y is down here into my distance formula and end up with a formula that's entirely in x.
Mm.
Then I can take the derivative of it, set it equal to 0, and it's going to tell me what value of x makes the distance of that line the greatest or the shortest. This case, they're looking for the shortest. So we might have to apply a first derivative or a second derivative test to make sure that we're looking at a minimum, but that's going to be our concept. In other words, I can't go anywhere with that formula that I just checkmarked because it's a function of two different variables. So all these optimization problems is you have to get the thing a function of one variable. Well, I can do that because I have another equation over here that's defining y. So I can either substitute for x or y. It doesn't really matter. I'll go ahead and substitute for y. So I end up with distance equals the square root of x squared plus, this becomes x squared minus 3 in parentheses plus 2 all squared. Now I want to simplify that. And when you're simplifying complicated expressions like this, best way to do it is one step at a time.
Yeah.
Well, simplify that first. You always start from inside the parentheses and work your way out. So that becomes x squared minus 1 squared. Okay, now let's expand that, because you always want to simplify these as much as you can before you do much more with them. That's what that term squared is. getting more and more complicated. No, it doesn't. Notice what's going to happen here. You see how I got that?
Yeah.
Well, radical signs don't work very well in calculus, as you've discovered, I'm sure, by now.
Yeah.
Fractional exponents do, because we're so often applying the power rule.
Oh.
Apply the power rule to that. It's the derivative of the outside.
X, 1/2 times x to the 4th minus x squared plus 1 to the negative 1/2.
It's the derivative of the inside.
4x cubed minus 2x.
Now, since one of them has a negative exponent, we're going to put it in the denominator. We're going to leave the other in the numerator. And then we're going to apply our rules. That is the first, that's the first derivative. That's our distance first derivative. That's, call it d, as a function of x. And what do we know if we're trying to find out where the original d function is a minimum? What do we have to do with the first derivative?
Set it.
All optimization problems follow this same format. You set the first derivative equal to 0. Because if I have a function that looks like that, when I set the first derivative equal to 0, I find that point, that point, that point, and that point.
Yeah.
Well, that would be the minimum, right?
Yeah.
Especially if I'm only dealing with that part of the function, that's clearly a minimum. But your minimums and maximums occur when the slope of the tangent line equals 0. Always remember that in calculus, that's what first derivative means. It's not just the slope of the tangent line, but the instantaneous rate of change. And when you're at a relative extreme point, that's where it's equal to 0. So again, I'm going to set that equal to 0, which means what?
You set the numerator equal to 0.
Correct. Solve that.
So you can add 2x to both sides.
Actually, no. That's a really common mistake, one that I made myself for many, many years until I realized that that's not the way to solve this. If I were to do that, then your next step is going to be divide both sides by x, get rid of the 4 and the 2, and solve it, right?
And then 0 wouldn't be a
Here's what happens. Let me just show you what happens. I'm going to do it the incorrect way, just to show you why it's incorrect. That's what you get when you do it that way.
Right.
Notice the solution we lost. Clearly, if we look at the original equation, x can be equal to 0, and it satisfies that equation.
Yeah.
Whenever you divide both sides of an equation by a variable that might end up being able to be 0, you lose that solution. Automatically, it disappears like magic. Notice that when we did that, we got 2 solutions, but 0 wasn't one of them. And yet, 0 is a solution here. And how do you get it? Well, you don't divide by a variable. Never divide both sides of an equation by a variable if it's possible that that variable could be 0.
Okay.
And in this case, it can be. So the solution lies in factoring. Now, from this, either that's 0 or that's 0. So either x is 0 or x is plus or minus 1 over root 2, which rationalizes to plus or minus root 2 over 2. Notice that we have 3 solutions this way. Okay? Now, that still doesn't tell us which one is the minimum.
Mm-hmm.
But if we go back to our original distance formula, as a function of x, this one right here, we can plug in all 3 of those values and figure out what's the minimum distance. Well, the first value was 0, right?
Right.
So d of 0 equals 1, square root of 1, which is 1.
Yep.
What is d of 1 over root 2, or root 2 over 2? In fact, it's a little easier to do the math if we do rationalize that. Make it root 2 over 2. What's that going to be equal to? Because remember, we're looking for the smallest number. So what's root 2 over 2 to the 4th? What's that equal to?
8 over root 2.
Actually, that's going to square to 2 and square again to 4. So it becomes 4 over 16, that term, minus root 2 over 2 squared, which becomes 2 over 4, which is 8 over 16, plus 1. That's a smaller number.
Yeah.
In other words, I've got 4/16 minus 8/16, which is minus 4/16, plus 1, that's 3/4.
Yeah.
So that's the square root of 3/4, which is a smaller distance than 1 is. So far, that's my favorite answer. In other words, that's where it's the shortest distance, is at root 2 over 2. Man, that's a tough problem.
Yeah.
But we have to check our third solution, which is minus root 2 over 2. And if you look at that, minus root 2 over 2 is going to cube to the same 4/16.
Yeah.
And it's going to square to the same 8/16. So d of this is the same as d of the other, which means we have 2 negatives at negative root 2 over 2 and positive root 2 over 2. Both of those values for x produce the shortest distance.
Okay.
And that's shocking to me because I would have said, looking at the curve, the shortest distance has got to be that distance right there, which is 1.
Yeah, it looks like it.
Well, only because I've drawn it that way.
Oh.
In other words, if I draw this parabola slightly different, now I go to this point, 0, 2, it's not so clear what the shortest distance is.
Yeah.
Turns out that it's not there. It's like there.
Yeah.
In other words, that is minus root 2 over 2, which is about minus 0.7, and there, and that is plus root 2 over 2. So this is actually a wonderful problem in that it absolutely requires calculus. There is no pre-calculus method that would ever allow you to answer this question.
Yeah.
It would be impossible. I mean, you could do trial and error for 10 years and you would not come up with that answer. So that's why this is a great calculus question. This is what calculus was born for, is to optimize these kind of things, which could not be done in any other way. Now, hopefully I didn't make a mistake here. I do hope that this is the answer because it's not the obvious answer, and the only way we got it really was by doing the calculus of it.
Yeah.
And we did end up with an odd answer.
Yeah.
Although it's odd in one respect only. In other words, if that truly is the answer, we can see that we have symmetry about the y-axis, so there has to be another point over there that's just as close, right?
Right.
So the fact that we came up with 2 answers is a little comforting.
Yeah.
Because we would not have wanted to come up with just that. That could not be right because of the symmetry here. In other words, the symmetry says that if we come up with any answer other than x equals 0, there better be 2 of them.
Yeah.
X equals 0 would be that point right there, and that would be the only point that you wouldn't have to figure out the symmetrical point. All right. I almost hate to spend as much of our session on that problem because you might get a problem like that, but not more than one.
Yeah.
It took us 10 minutes or 15 minutes to solve that.
Yeah.
And that was pretty much straightforward solving it, not with a lot of explanation. So, what else you got?
This one is find the fractional or the partial fractional decomposition of 5x plus 3 over x squared minus 3x minus 10.
Okay. These are decomposition of partial fractions can be easy, can be tough. This one's easy. And why it's important is if I wanted to take the integral of that, I would have a devil of a time doing it. Have you had integrals yet? Integration?
No, I don't think so.
Well, that's the reason we need partial fraction decomposition. Is because we don't know how to take the integral of that, but what we do know how to take is the integral of the sum of 2 things. In other words, I know how to take the integral of the a plus the integral of b. That's a piece of cake. Or even, if I say the integral of a plus b, that's a piece of cake. That's the integral of a plus the integral of b. But if I say, what's the integral of a divided by b? That can be an hour-long problem.
Yeah.
So integration is a lot different than differentiation. Even though it's the inverse, it's just a lot harder. There's no such thing as a quotient rule. There's no really anything such as a product rule. So integration is a lot tougher. But one of the techniques of integration is to separate a fraction into its partial fractions. Okay? And the best way, I can finish this problem in probably 5 minutes, which is what we have. Let me just start out by saying that if I had 1 over x plus 1 over y, I would solve that by finding a common denominator. With me?
Yeah.
And that would end up being y plus x over xy. Well, what if I started with that? If I started with that and I said separate it into two fractions, well, it wouldn't be obvious how to do it, right?
Yeah.
The trick is that the bottom is the product of two things. So I'm going to show you how to separate them. In other words, given the result, how do you take it back into two fractions? Well, the first thing you do is factor the bottom. I'm going to speed it up here a little bit. Now, this is really what we were looking at. Notice that our bottom is the product of two things.
Yeah.
So I can actually say this, that 5x plus 3 over x minus 5 times x plus 2 must be equal to something over x minus 5 plus something over x plus 2. You see how we make that leap?
Yeah.
Because if I started with this on the right, what I would do is find a common denominator, which would be this on the left, and then I would figure out what the numerator of each would be.
Right.
Okay? So if we started on the right, what we would have is a times x plus 2 plus b times x minus 5 all over the common denominator, which is this. So now I can make this statement. It's not easy, but it's kind of fun after you do a few of them because it's very clever. You see how I get on the right? Because all I did was I add those two fractions together using a common denominator.
Yes.
Now, I've got this denominator is the same as this denominator, therefore my numerators have to be equal.
Right.
So I can now make the following statement. 5x plus 3 equals a times x plus 2 plus b times x minus 5. Well, still not the easiest thing to solve. I got 3 variables, only 1 equation. But here's the thing. That is a true statement for all values of x. Which means I can solve for a and b by picking certain values of x. Notice that if I pick x equal minus 2, what's going to happen? The left side becomes minus 7. The a term disappears, and I get equals b times minus 2 minus 5 minus 7. That solves for b. b equals 1. So b equals 1. And now, by a very similar method, I'm going to solve for a by letting x equal what?
5.
Now I get 28 on the left equals 7a plus 0, because the b term goes away automatically. A equals 4.
Oh.
So I got a equals 4, b equals 1, which means if I go back to this part of the equation, a equals 4, b equals 1, there's your answer. We've decomposed it into these two partial fractions. Now, if your life depended on it, in other words, if somebody said you will live or die based on this being correct, you would go back and add those two fractions and make sure you got that, right?
Yeah.
Well, that's what you want to do, if you have time. Now, whenever you're taking a test, you don't always have time. So you kind of have to sometimes just live with your answer if speed is an issue. But like I said, if my life depended on it, I'm adding that back together. Well, how do I add that back together? I have a common denominator of x minus 5 times x plus 2. This numerator is 4 times x plus 2. This numerator is 1 times x minus 5. If I simplify the numerators, I have 5x plus 3 all over x minus 5 times x plus 2. So indeed, that is the decomposition of that. Now, why is that ever needed? Because calculus, if I want to integrate, I don't know how to integrate that, but I definitely know how to integrate those two. Because you can integrate two things being added together. It's hard to integrate two things being divided. And you will learn how that's an easy integral to do there, and so is that. Whereas this is devilishly difficult. And in fact, the only way to do that integral is this method that I know of. You have to do the partial decomposition of the fraction. So I guess instead of getting you into integration, they decided to start here at the end of the year, which I don't mind. That's a good place to start.
Yeah.
Because once you get into integration, you're going to need this as one of your techniques. So,
Right.
so you said your test was when?
Monday.
So this is it, huh?
Yeah.
You feel prepared for it?
Hopefully.
Well, good luck.
Thank you.
It's been enjoyable working with you. And you're a senior, right?
A junior.
You're a junior, so are you taking Calc BC next year?
I'm going to take AB.
You're going to take Calc AB. Okay, well, I'm available if you need me. Calc AB will get into integration also, a little bit.
Okay.
Actually more than a little bit. That'll probably be mainly what you deal with next year's integration. They'll review some differentiation with you, but most of the year will be integration. So,
Good.
let me know if I can be of help. Okay, Brianna?
Awesome.
Have a good summer.
Thank you. You too.
Bye-bye.